September of 2012, we left our home port of Seattle on a trip around the world in our Nordhavn 52 Dirona. Hello, this is James and Jennifer Hamilton aboard Nordhavn 52 Dirona in Amsterdam. We've just arrived and plan to spend the winter here. As usual, we'll get a few onboard projects done before we head back boating early next year. If you'd like to learn more about our around the world trip, you can read all about it at mvdirona.com.
Here we're going to do a larger service item on a Lugger L844d auxiliary marine propulsion engine. Today we'll change the power takeoff unit clutch, and this is an engine that's very similar in fact it's exactly the same as the engine used in the Northern Lights L844d 16 kilowatt generator, and it's also very similar to that used on the 12 kilowatt generator that we have on board Dirona.
Okay, let's get started.
Indeed. Alright, here we are down in the engine room, and this is the wing engine as I described earlier. The wing engine, just to give a little bit of context, this is responsible for emergency propulsion on Dirona. The main engine, which is right here, this is the beast that does all the work. And so it's the single engine that drives Dirona on all of our passages, including crossing oceans. And it drives through this transmission, through this shaft, to the main propeller assembly. To have a single engine makes sense for an ocean-going vessel, a small one, because you just don't have the space on board for sufficient fuel. And if you go with a dual engine, you reduce the space for fuel, and it's a tiny amount less efficient. But of course, you'd never want to have a single engine 1,000 miles off shore, middle of an ocean. So we have an emergency engine right here. This is a 40 horsepower Lugger L844d. This particular engine is two main purposes. Let's first talk about the emergency propulsion use. This is a separate engine, separate shaft, separate transmission, separate fuel pump, separate electrical, separate batteries. It is 100% separate from this main engine. If we get hit by lightning, if nets tangle up the propeller, anything goes wrong at all, this engine should be ready to go and still able to move Dirona along at about 4.5 knots. Now, in order to do that, we've got, as I said, all separate components, including the fuel tank. The good news about that design is it means the boat is safe at sea and will be able to proceed even in the unlikely event that there's an engine failure in the main engine. The bad thing about that design is this engine probably will never get used. If it does get used, it'll be used once every 3 or 4 years. Very uncommon. The bad thing about that is it won't be there when you need it. Engines that don't get used rust inside, generally just get worse and worse over time, and many times when people go to use them, they're not there. So arguably a good part of the design on Dirona is it's a hydraulically driven boat, which means the thrusters, the emergency bilge pump, the windlass, the stabilizers, all work off hydraulics. There's a pump on the main engine right here underneath this, and there's an identical pump on the wing engine forward. The good thing about this design is it's redundant, and so if either fails, we still have hydraulics, which is, of course, you want everything on an ocean-going vessel to be redundant. The second good thing about it is this engine gets exercise. Because this engine's idling in close quarters situations, when you need to use the thruster, this engine will be running at full power, so you've got full authority on the thrusters, and it means this engine gets exercised anytime the anchor goes up and down running the windlass, anytime we're in close quarters running the thrusters. So we get on average about 100 hours a year on this engine, and as a consequence there's 1,000 hours on it in 10 years. So it does get used. So the combination is what I view as a good combination, where it's tested and exercised constantly, gets proper maintenance, you know if there's anything wrong with it, but it's available if in the case of an emergency for propulsion applications, and when under propulsion, the stabilizers still work because it has its own hydraulic pump. What we're going to do today is underneath here. So what I think I'll do is I'll start with taking this step off and having a look at what we're going to work on. Here it comes. So to shift this down and get it out of the way. So what we've got here is a hydraulic pump, is this section right here. It's a Rexroth 45cc pump. This is the clutch that allows the pump to be disconnected from the engine. This is the front of the engine, which seems a little odd, I suppose, but since the back of the boat is that way. But this engine is front points to the rear because it's a Z drive. The engine drives the transmission out there, which drives a prop shaft towards the back of the boat. This is the front of the engine where the hydraulic pump is driven off of. Let's talk about why there is a clutch on this hydraulic pump. Since that's the faulty component, it's worth understanding. Why do you want that component in the first place? On the main engine, underneath here, the same pump is driven by the main, but it's what's referred to as a live pump. And what a live pump means is the pump is always connected to the engine. The good thing about that is you avoid the complexity or fault modes that come with a hydraulic clutch. The bad thing about that is if the main engine's turning, the hydraulic pump's turning. And which means if you have a hydraulic line that breaks, the only way to stop the hydraulic pressure and stop the leaking fluid is to shut off the main engine. The last thing you'd want is to not be able to run the main engine because of a hydraulic leak or a serious problem, and also not be able to run the emergency engine because of the same leak, not wanting to run the same pump. So the clutch allows it to be disconnected. Wonderful design. I would actually much rather have a clutch on the main engine as well, just because it gives a little bit more flexibility, a little bit more capabilities in the case of emergency. However, it is the clutch that's having problems today. Let's talk a little bit about how the clutch works and why it's there. As described earlier, the clutch is underneath this cover in here, and in a few minutes we're going to open that up and see what it looks like. But let's start by looking at a clutch and figuring out how it works so we know what to expect. This clutch has three main components. This front component right here is connected to the engine, and whenever the engine rotates, this rotates. This middle component, it looks like the back, is held rigid, and that's what holds this assembly in place. This outer unit is also connected to the center shaft, and when it rotates, this shaft rotates. If you look carefully right here, you'll see there's a clutch plate on either side of that. When this electrical line right here, this line, when it gets energized, it creates a magnetic field in here which closes this clutch. The impact of closing the clutch is to connect this side with this side, which means the clutch is connected. This outer piece that stays still, stationary, which of course has the electrical line in it, is always got bearing separated, or this other assembly is separated from here with a bearing. The clutch decides whether this side is directly connected to the other side or allowed to spin free. When it spins free, as it is here, the clutch is disconnected. When that's disconnected, there's a bearing, and this is the bearing right here that's between those two parts. So when it's disconnected, this bearing is rotating. And when the clutch closes, the whole assembly turns as a unit and is not rotating. And ironically, most bearings you'd expect would wear out when they're used. This bearing fails when it's not used. What happens is when the clutch is closed, this piece rotates together, and a 4-cylinder diesel is going to vibrate a little bit. And because it vibrates, the bearing just sits there in place, shaking like this, And over time, the ball bearings wear through the grease layer, and they just pound against the edges of the race. Over time, that'll do damage. And the damage that gets done is called false brittling. And then what happens is when the bearing spins, it'll make noise crossing those rough spots, and the rough spots will get worse because rough spots cause more rough spots, which cause more rough spots. And so over time, the bearing will fail. There's 3 ways to manage this problem. One is, whenever the engine's running, don't run it at idle, run it at higher RPMs. Higher RPMs is less vibration, tends to produce false brittling less frequently. Second thing is, only have the clutch closed when it needs to be closed. So if the clutch doesn't need to be closed, leave it open and let it spin free, which will cause this bearing to spin, and it will not suffer from false brittling. However, since the whole purpose of this assembly is to have the clutch closed to drive the hydraulics, clearly it needs to be closed when it's working. And indeed it is. The last defense is a really innovative solution that Northern Lights put in place to help these clutches last longer. And what they do is every 10 minutes, they release the clutch for about 300 milliseconds to 500 milliseconds, about a half second. So they release the clutch for half a second, it rotates just a little bit, and then closes down again. When you're operating the hydraulics, you can't even tell it happened. You'll hear a little change in tone, but that'll be it. The act of changing positions every 10 minutes means the false brittling is greatly delayed. And that's why this engine has 1,036 hours, and we're just getting ready to change this bearing for the first time. Now I think what I'll do next is, rather than open it up right away, I think what I'll do is I'll start it so you can hear what it sounds like and hear what a faulty bearing sounds like and know why it needs to be changed. Okay, to demonstrate this problem, what I'm planning to do is I'm going to start up the engine, and then I'm going to, of course, when it's started, the clutch will initially be disengaged. So we'll start the engine, you'll hear it idling, it'll be making some noise, because what's happening is when the clutch is disengaged, the bearing is rotating and it's grinding away because the bearing is worn out. Then what I'll do is I'll turn the hydraulic system on. When I turn the hydraulic system on, you'll hear it go away, and then the difference is normal diesel engine noise versus the noise with that bad bearing. And you can quite distinctly hear the difference between them. And I think when I go upstairs, maybe to make it particularly obvious, I'll turn it off and turn it on a couple times just so you can hear the difference. All right, let's start it up. I've just pressed start on the WaveNet control. It's currently engaged the glow plugs, and the engine's getting ready to start, and it will I'll go turn it off and on. Okay, this is what it should sound like. That latter bit was the way it should sound. The high-pitched metallic noise is the failing clutch. And so the reason why we know it's a clutch is when we disengage the hydraulics, you can hear the noise quite distinctly. When you engage the hydraulic clutch, it gets quiet, returns to a normal diesel engine sound. So we know we need to do something with that. The question is, when do we need to do it? It's been making a little bit of noise over the past year and a half. It probably would go another year, almost certainly. But there is some risk that it eventually could catastrophically fail. And so you want to get to it before there's any risk of catastrophic failure disabling the system entirely. So we've decided, while we're in Amsterdam we're going to be here for a while, might as well get some of these bigger jobs done, especially if there's a chance that we might need some extra parts. I've done my best, in fact, I've done my best dating back about 10 years ago to get the parts we need to eventually do this job, because it is a wear item, and so I know I'm going to need to do it eventually. I've not done this job before, and so a certain amount of trepidation on that. Also, I have, but good news is I've seen it done once by Scott, by Scott Diebold, who's the customer service manager at Northern Lights. Scott is a very gifted mechanic. He's one of those guys that can overhaul an engine wearing a white suit and walk away without a drip anywhere, not a mark on that suit anywhere. He's phenomenal. Normally the kind of skills you only see around race cars. So the good news is I've seen Scott do this job. Bad news is it looked kind of hard when Scott did it, and so I've got to admit I'm not totally looking forward to it myself. I've been very tempted to offer Scott a flight over from Seattle to Amsterdam to enjoy the beautiful scenery here and maybe spend some time in our engine room and change that clutch. But the danger is he's such a nice person, he'd probably say yes. So we're going to do this ourselves. The first step of this job is to remove that Rexroth 45cc hydraulic pump. What I'm going to do is remove two 19mm hex screws that hold it onto the clutch assembly, and then carefully pull those splines out, working against the hosing, and move the pump off to the side so we can work on the clutch. One of the hard parts about getting the assembly off there, well, first thing is the hoses are really stiff, so they'll block. And the second thing is the threads will be rusted or corroded and a little bit worn, and so the splines, and so they can be relatively difficult. I'm using a pry bar right now just because I have been unable to shift it free, and so the pry bar, you got to be very careful. There can be no nicks, nothing on that surface, and so it's really not something you should use, but it's so tight I'm unable to get it otherwise. There's this little gap in here that I've been using to lean on, and it is coming free. It is a 1/8" gap opened up now, and so we're progressing. And that slowly, steadily is opening up. You can see now it's about 1/4" gap. It's pretty close to coming off, I think. It's just too difficult. There it goes. That's free now. There we go. You see what's happening is the pump is so heavy it jams up the splines. So we've got it now. I'm just going to pull it to the side and tie it off, giving me some room to work. So this is basically done at this point.
That looks like a heavy item.
It's not as it's heavy, but what's really a problem is the stiffness of the hydraulic lines. So what I'm doing now is putting a trailer strap on it to pull it out of the way, so that I don't have to hold it with my knee, and it won't swing back into the way.
That looks like a great solution.
Yeah. See, that's stable right there. So now, with the heavy stuff stable, the rest is easy.
Great.
Or easier.
Okay.
Here you can see why it was a little bit of work to back away the pump from the clutch. There's a little bit of rust in the splines. This is normal. It's going to happen over time, and it hangs up these relatively close fitting components and makes them a little bit difficult to pop apart.
And here's Spitfire coming to inspect the job so far.
What's up, little guy? Wanted to come back after the fact and just slip this section in. We didn't get good video of me removing the taper pins, and it's an important part of the project, so I wanted to show it to you in detail here. So we're kind of coming back to it after the fact. The taper pins I'm referring to are right there and right there, and the same on the other side. These two pins on either side hold the clutch assembly in alignment. It's super important that the taper pins be removed cleanly and installed cleanly. They're not that hard to work with as long as there's not a lot of corrosion in the area. I was a little bit worried about ours because the raw water cooling pump, which is right here, as you can see, it's been replaced. It failed. It had a bearing failure at one point where it sprayed a little bit of salt water in the area, and as a consequence, the taper pins on that side were a little bit corroded, quite corroded actually. This side wasn't a problem. In the end, the pins came out cleanly, but I wanted to give you a little bit of advice or some observations on how to get the pins out cleanly. First thing that's important is good quality vice grips, which normally, I always, whenever I'm using vice grips around a mechanical job, I'm always a little bit embarrassed, but that is the right this is one of the few places where vice grips are the right tool for the job. What you're looking for on vice grips is good quality, hardened steel jaws, and really sharp edges. And what we're going to do is we're going to get a good grip onto the pins like this, and we're going to show good patience. It's important to show good patience, and you're just working it back and forth while pulling out. And with rotating it back and forth and working it out, they'll come out fine. The trick is, though, you don't want to damage them. And so here's an example. We're in like that. We get the vice grip as tight as we could possibly get it, and then we work it back and forth, back and forth, back and forth, and pull it out. If it takes 5 minutes, perfectly fine. If it takes 10 minutes, also fine. If you damage anything in this area, it's a problem. So you really want to get the pins out of there cleanly. You can see right there, I've replaced all 4 pins, and these are the new pins in there now. It's super important that you go with new pins once the job is done, even if you do almost no damage to the ones that are there. You want to start off with brand new pins, nice alignment. I like to put a small amount of grease on them so that they're a little bit easier to remove in the future. So that's it. Not hard, but it does need to be done with a little bit of care and, as I said, a little bit of patience. At this point, we've got the taper pins out, but the cap screws that are holding the clutch assembly in place are still there. Nope. Need a bigger one? Bigger handle on that.
Did you get it?
Yeah. And what I'm doing right now is I'm using a 10mm Allen key to remove the attachment between the hub and the rubber damper that drives the clutch itself. This rubber damper is held in by 4 10mm cap screws. I'm going to back all of those out first so that it's free, and then take the clutch off and carefully lift it away.
So what are you removing right now?
I'm removing 4 bolts that hold this flex coupling that the engine drives to the input shaft on the clutch. These have been Loctite on the ends to keep them securely in place, and that's why the last little bit's difficult to get out because it's jamming up in Loctite. But beautifully beautifully installed in that they're greased at the top so they don't jam up with the rubber, and Loctite at the bottom so that they never come out, and yet still serviceable. So that's ready to go right now. There's 2 bolts holding this on there.
And that is the clutch itself?
That's the clutch assembly itself. It's about 40 or 50 pounds, so I have to keep an eye on it when I undo it. I'm going to take this cover off next, just because it's in our way, and we want to check that belt. Almost certainly replace it. That's the drive belt. You can see it's a little loose, a little bit of wear, but really in very good shape. I'll still change it just because it's open now and can be changed, whereas otherwise you can't because of all of this power takeoff assembly here. So we'll definitely change that. These are all apart, so I just got to now slide that clutch out of there, and then once we get the clutch out, I'll get a better look at what's required to change the failed bearing inside. And you can see Spitfire has been crossing over constantly. There it is. And if you listen carefully, you can hear the defective part.
How should it sound?
It should roll nice and smoothly and shouldn't have that rumbling noise. You can feel it in the bearing. So definitely needed to come apart.
Is that kind of scraping sound?
Yeah, that's right. Yeah. So now what we need to do is, I've never had this apart before, so I need to figure out how this comes apart from here. And you can see I'm pouring a little bit of rust and other little bits of debris around. And you can hear Spitfire in the background, most unhappy. Not nearly enough attention today.
And that's a little pile of bolts and things that you've taken off?
Yeah, that's all the parts. They're not all, but yeah, most of the parts I've removed so far.
Yeah.
Do you know where the vacuum is?
The little one?
Yeah.
Oh, I got it right here.
Yeah, pass that down. Okay, so there's the assembly outside. I'm just going to very lightly mark it so that I know for sure how to reassemble it. Oh. Here we're just taking the protection off the clutch power cable. So that we can slide it out of the cover. And so now we're looking at the final clutch assembly.
And that's the same piece that we were just looking at earlier.
It is. This particular clutch is made by Pitts Industries in Dallas, Texas. It gives us part number right here. We've got a spare upstairs that we were looking at earlier. What I'm tempted to do is rather than changing the bearing in this unit, just drop in the new one as it's laid out here, and then change the bearing and whatever parts need to be replaced in the other unit at another time. I think what I'll do now is go into cleanup mode, where first I'll clean all of this, everything around here. Specifically, I'll clean with a wire wheel all of the surfaces with any signs of rust whatsoever. This will have a little bit of lubricant on it to keep it from rusting. I'll clean off these faces to make sure that the rust doesn't cause any misalignment when I bolt things up. And I'm going to very carefully check for any wear on this rubber assembly right here. And given the age of the system at 10 years old, and looking at it just from here, I think I'll probably just replace that as well.
And what is that rubber part?
That's the rubber torsional damper that takes up any misalignment between the two parts, subtle misalignments, and also provides some torsional damping as well. And so I'll replace that just because it's 10 years old and it's not worth opening up again. Fair amount of rust on some components, so I'll take my time and clean that up as well. Okay, what I've done is I've cleaned all the corrosion off of all of these surfaces, all through there. This is the new clutch, and I've cleaned this assembly up entirely. And one of the most important things when you're putting things together is to get it clean. Now, next thing I'm going to do is put a very light coating of grease on the splines of the pump, just to keep that corrosion down. Is the reason why it was hard to come apart is a little bit of rust in there, and just a tiny amount of grease can help fix that up. Next thing I'll do is I'll test to make sure that it actually fits together properly and it's the right part, or apparently the right part. And it's going in there nicely. So that's good. Just removing any excess grease because we don't want grease flying around in there. So here is the cover for the clutch, and here's the new clutch. I should probably mention right now that I elected, rather than changing the bearing, I elected to just change the entire clutch, and I can get the bearing pressed in properly at a machine shop that has the appropriate equipment once we get this thing operational again. Now I'm just trying to get this aligned properly. That's close, but not quite. That's perfect. Right about there. Okay, so that's now the way I want that to be. I have to get the rubber boot that goes on here. I'm just going to get a little bit of silicone and a screwdriver to lightly feed that into place. In order to get that rubber boot on there, I just wanted to lubricate it a little bit with silicone. And now feed the boot in there. Okay, so that is the assembly right there with the new clutch in place. And these wires will need new connections on the end. I've got a little bit more cleaning up to do in there, but it's generally, everything right here is pretty good. I think I'm ready to slip the clutch back into place and carefully align it on these pins. So what I'm going to do is get ready by having 4 bolts available, so I can just get a couple of them to hang it from. And this assembly has to go just right too, so it might be a little challenging. Right now I'm just putting in the 4 top bolts loosely because it's not aligned yet. I'll need to align it with new pins. But I want to first get these central section properly installed. So I'm gently guiding that into place and just doing it up finger tight. Because what I'm going to do is once I get 2 of them in there, I'm going to come back and put first I'm going to put Loctite on this section, grease on this section, and put 2 in, and then I'll take these 2 that I'm temporarily putting in place back out again. The reason I put these temporary in these in temporarily is I want to get it exactly lined up first before I put the final section in with Loctite. And because these seem to be difficult to align, I think what I'll do is I'll probably put all 4 in, or put 3 in, then do one at a time with Loctite. You can see the alignment has to be just perfect or it will not go together. You can see how careful the alignment's quite sensitive, where I've just got 2 in there, but 1's snug enough to cause friction, so I can't get alignment on the 3rd. Having seen that, I'll be very careful and put all 4 in, and then get them all settled in place, and then take 1 at a time out for final Loctiting. That's all 4. So now what I'm going to do is snug each one of these down, back it off a little bit, and then carefully do up each one evenly. So each one right now was loosely tightened in, loosely tightened, if you will, loosely attached. And now I'm putting each one just snug, not very tight, maybe 5 pounds-foot of torque, not very much at all. So they're now all done up, just fairly loosely. And now what I'm going to do is I'm going to take each one out one at a time for final installation, now that I've got just the alignment that I want. So what I'm going to do is clean the threads up, put Loctite there, put grease there, install one, tighten it down, do the next one, do the next one, do the next one. Then I'll go back around and torque them all to the torque specifications, which is, as I recall, is 59 foot-pounds, but I'll check on that as well. What I've done right now is I snug down all 4 of those attachment bolts to the hub. Then I loosened off one at a time, cleaned the threads, and applied Loctite and grease. And I'll do one more, this final one, to show you. So it comes back out, 3 are still holding it, so it's well aligned. Clean the threads up where the Loctite was from the previous install, so they're nice and clean. A little bit of grease, and the grease is there so that the rubber doesn't twist on reassembly. That's in there right. A little bit of Loctite, blue, so we can get it off. So now all 4 are installed, and I need to go get a torque wrench, and I'm going to torque each one of those to 59 foot-pounds. Here's a torque wrench, and keep the torque wrench on 0 torque so that it doesn't go out of calibration. And now I'm turning it up 35 foot-pounds, 45, 59. So that's ready to go.
And how does a torque wrench work?
Torque wrench works by, it bends a bar inside, and then it goes over a detent and goes clunk, and it's set up with a spring against the bar such that it will signal the proper torque that's been adjusted on the spring. So that was that click you're looking for. So I normally do it 3 times, but I'm certain it's no different than once. And because I'm careful, I will check all 4 of them again. So that was the 4th one. So this is the first of round 2. So you can see it's not moving anymore, which says that the torque was right the first time. So I'm going to check one more and I call it a day. And I'll loosen the torque wrench off all the way for storage. And put it back away. Okay, so I've just put this belt cover on, done that bolt up, done the bolt up on the other side, and wire tied this out of the way so the spare belt doesn't get in the way. This spare belt's available in case the main belt breaks, in which case you just cut that wire tie, slide it in, put it on, and do it up again. Avoids having to do all this work over again. I've gently pushed the pins in to align everything. And now what I'm going to do is pull them out one at a time, put a little bit of lubricant on each, and then gently tap them in place for final alignment. That's the first of the 4 pins. And that pin's not going in, so it's not quite aligned. There we go. That's aligned there. Super, super, super sensitive. Tiny shifts. Okay, so that's all 4 pins in place. Now I'm going to very gently tap them so they're fully in place. So the pins are now holding it firmly. So then what I'll do is I'll tighten down the attachment bolts. I've had the pump pulled away and held in place by a trailer strap, pulling it away from where I'm working, so it's good clearance. We're ready to put the pump back on. So the first step is I'm going to remove the trailer strap. Then the pump will just be hanging by the hoses, and I'll lift it into place and slide that spline into the clutch. It's just, unfortunately, those hoses are really tight.
Hard to get it back in position.
It is. Oh, it seems like it's going. Oh, wow. That was easy.
I thought that was going to be one of the worst parts of the job, is dealing with that.
Me too. Okay, well, that's it. Little Loctite on both of these. Having a little trouble finding that hole. I think I have it. Yep. So that one's wound in finger tight. This one should go in easier because we've now got it aligned properly. Okay, could you pass me a 19 mil wrench?
Okay.
Okay. Trying to gently pull these in just a little bit at a time so it's nice and even. And I'm shaking it a little bit to make sure it seats in properly. It's now snug. Great. At this point, it's electrically not yet complete. In that we need to do a little put that wire in properly. But mechanically, it's not quite. You need to clean it up a little bit more. But basically, it's ready to run right now. So we're very close to done. A little bit of work on cleanup. That's about it. I think I'm gonna call it a day here, just because it's 10 to 6, close to the end of the day. There's only a tiny amount of work left in this. I'd say probably 45 minutes, something like that. But from my perspective, I'd rather do it tomorrow morning after I get some other work done. And so do the rest then, and start it up tomorrow morning. I'm pretty optimistic. It went surprisingly well. I thought this would easily take twice as long. It's actually it's gone very nicely.
That was a lot less daunting job than I was expecting. I'm amazed how fast it went.
Yeah, I think I oversold it. It's good. Yeah. All right, getting close to done. We quit work last night at about 10 to 6. Started up this morning at 8. And basically all that's been done is I just finished wiring in the clutch itself, so it's wired in, tied off the wire ties, cleaned up this area just so we can see where things stand, and we're now at the point where it's ready for test. If it passes test, then I'm going to scrub the floors, put everything back together, and get it all looking the way it's supposed to look again. But generally, I feel pretty good about this one. It feels like it's gone much better than I expected. Of course, game time is when you find out how well it went. So let's give it a start and see how it did. Glow plugs are on. It's getting ready to start. Nice to see. No audible difference whether the clutch is closed or open. So we're 100% back to operational. What I need to do now is just a good cleanup and button this up and declare success.
Nice work.
Thank you. Thanks for the help.
You can read more about our trip around the world at mvdirona.com, including an interactive map showing our track with a live update of our current location.